Good morning, good afternoon, good evening, everyone. I hope everyone is doing fine and appreciate you being here again on Saturday and going through a technical and behavioral journey for becoming a solution architect. I'm really happy to be on the fifth week because we would be starting the solution architect track. Last 4 week we covered about cloud practitioner. We would now focus more on the little bit more on the why and how part. In the previous track, what we talked about is what is a service, why, what would be the benefit of this, and now we will focus more on the deep dive part of it, and we will understand what could be the way of configuring something and how that would be configured, why a customer would use it. So this will be more on the why and the how part of it. As an icebreaker activity, can everyone let me know which country is in your bucket list to visit? Like you are planning to visit that country maybe in 2 3 years, or maybe before you reach to the point when you cannot travel, but anything which you have in your bucket list for travel, let me know. For me, it is Japan. So I don't know how, but I always get fascinated by Japan. Good of mixture of technical thing as well as culture. So I'm planning probably next year. Hopefully, I should be able to go for it. Huge list. I agree on that, Allah. It could not be one single country, and now I have to reveal the second one too. So for me, first is Japan, and second is Cuba. I'm not sure why, but yeah, these are the two. Please, Mars. Kapil, you need to wait a little bit or push Elon Musk more so that he can create the rocket to take you to Mars. You would need that. Finland, it's a nice place. Agree. USA obviously is it's a vibrant place. Thailand, Andy, I like that too. Yeah, means if you want to just relax, chill out, Thailand is the best place. I would say Iceland, completely agree on that too. Maldives, yeah, I haven't been there, but yeah, it's a good place. UK is obviously lots and lots of mixed cultural place, so that could be one thing. Sweden, Ghana. Sweden has one of my bucket list. Good. And okay, so we have some people here from Sweden too. So maybe you could work as a guide to help out people. And then we have Kenya, New Zealand. Yeah, I'm picking my list also from this. Whole Europe, I like that, Pawan. Yeah, means maybe backpacking in Europe, that would make sense. Switzerland, Bhutan, that's an interesting one, Prasad. Yeah, so Bhutan, people might be knowing it already that they like countries measure GDP, and that country Bhutan, they measure the gross happiness of people or citizens. So really interesting way to look at how the life is there. Kenya. Thank you so much, everyone, and I'll not take so much of time, but I want to talk about some of the statistics which is coming from last program. And before that, I want to talk about the theme for this particular session. Now, one more question. Mount Everest, thank you, Bala. That is interesting. I can't do that. I don't have that kind of physical endurance, so I won't dare that. Now, we will be focusing more here today on the solution architect, and we would be focusing on that how you can be consistently preparing for things. And in next week we will talk about behavioral aspects also, where we will be analyzing the videos we have created so far, or means the sessions we have delivered, and we'll find out that how you can pick up the pieces of behavioral way of answering question when a SA is talking or when you are talking to customers. So that would be owned by Prasad. Next week onward, we would have those analysis of the videos where you can pick up the behavioral skills also. So that's what we would be doing. Now, does anyone remember this movie? This is a movie poster. Anyone? Any movie buffs here? I like to watch movie at least once in a week or twice in a week. So anyone who knows about this movie poster, let me know in the chat later. Shouldn't be a problem, but we'll quickly get started in interest of time. So I want to share one more fact here. This is how the weekly emails look like. Shawshank Redemption, agree on that, Bala. Yeah, that is the one. That's the one. If you haven't watched it, please check. It's an interesting movie. I think it is the highest rated movie on IMDb, so you should check it. Now, talking about the facts here, so we sent around 3,700 email every week, sorry, and out of that, you could see some statistics here that 75% maximum get opened. That's max number, which was on first week. Everyone was enthusiastic to become a solution architect, learn about technology, but obviously, when you put a graph about motivation, it goes up and it goes down. But when you put a graph of consistency, it's straight as a straight line. So make sure you are in the straight line of consistency, not just being motivated for 1 week and next week you have no idea what you are doing. So make sure you are in that. And if you look here, The resources are only clicked by a few digit of percentage, like 5%, 9%, and over week over week, this will obviously decrease. But I appreciate you still being here, and this is something which you should all stick to. What I always say, consistency. So that is the key. Bhupendra is having a question. How can I get email from PESA? Bhupendra, we send these emails every week, and if you are not on that list, ping me your email address, and I can look into it. That why you are not getting that email should not be problem. So be in that 5% list. Don't be into this 95% people who are not going through the content or who are just joining it and not doing any homework at all. So that doesn't help. You need consistent efforts for that. So that's all I wanted to talk about. And people who are consistent, we have some goodies for you. We will be conducting bonus sessions of well architected, and only people who are consistent, that 5% would get admission to this particular session, which is called well architected. So we'll do that. So we are on domain 1 for solution architect associate. We'll talk about designing and securing architecture. So let's go ahead and talk about this particular topic, and I would be adding today Parna and Nicole to help us with this particular topic. They would again do a role play, and they would be helping you in that way to understand about the topics related to solution architect. Hi Nicole. Hi Parna. Nicole, maybe.
Hello, hello.
Hello,
Hello.
everyone.
Good. So we have a consultant, we have a customer, enthusiastic customer who want to get lots of answer, and enthusiastic essay who is going to give those answers. So let that role play begin. I would be on backstage. If you have any question, put them into chat, and we would be happy to take it from there. All right. All the best. Thank you.
Hello, Pana.
Hey, hi, Nicole. How are you today, and how can I help you?
Yeah, I'm good. But the problem is that I have no idea what my tech teams are doing. And some of them also don't know what they're doing, which is okay for now. But, I was wondering, now that we no longer have a data center where we can actually plug cables into servers and all that, how do we go about it? So how would I build an architecture without access to a data center? And how could I secure this architecture? Do you have an example what that looks like and what kind of components I need to think of?
Definitely, Nicole. So, I'll give you a little overview about what setting up a network on the cloud on AWS is like. First of all, are you able to see my slides?
Yes.
Yes. Okay, that's good. All right. So, let's get started. So, setting up the network on AWS is very similar to how you set up a network on your on premises. So, what we build is called as a VPC or a virtual private cloud. So we have our AWS cloud, and as you know, we have multiple regions, and you need to select a region where you would create your virtual private cloud. So now, what is a VPC? It is an address space, a private address space. You can think of it as a plot of land which is given to you, and you can go and build whatever you like on it. So similarly, we will create our VPC, and we are going to create this VPC within a region. Now, every account per region, we have a limit of 5 VPCs that we can create, which is inclusive of a default VPC. So, if you ever open up the console, and let me just show it to you. So, currently, if you see, I am in North Virginia region. Okay, and if I take you to Mumbai region, where I don't have any VPC set up. And if I open that up, you'll see there is already a default VPC there.
Mm-hmm.
All right. So what you see over here, I have not created it. This is a default VPC. And how will you come to know about it? If you look out here, it says default VPC, yes. Okay, so this is inclusive of the total of 5 VPCs that you can have per region in every account. So coming back to what exactly is this VPC? So when you create this virtual private space or an address space, you need to opt for how many availability zones you want to use. Now, if it is just for development purpose or for testing workloads, then you could as well use just one availability zone. But however, for a production workload, you want high availability, it is recommended that you leverage two or more availability zones. So you can see that I've created a VPC, and what you see over here, the 10.0.0.0/16, that's called as a cider block. Okay, that is my address range. Cider block, you need to assign a cider block when you're creating your VPC, and I'll show you where you assign that. This is an IPv4 format. Of course, these days organizations like yourself can opt for IPv6 also, because as you know, IPv6 is enormous. The address space by IPv4 is very limited, and we are the rate at which the internet is growing, we will probably be running out of space, right? So just for simplicity, I'm just picking up the IPv4 address space, and this is a cider block that we assign. Once you've set up your VPC, as you can see here, and I've opted for two availability zones for high availability, I am going to chunk up the VPCs, meaning I'm going to segment my network. I'm going to keep certain resources in my public subnet. So I will split it up into public and private subnets. And ideally, what would you put in a public subnet? So, say you have a web application running. So, your web application servers will reside in the public subnet, and maybe your application layer servers or maybe your databases, which have to be private, meaning they should not be reachable from the internet. Probably they would want to talk to the internet, meaning egress requests, but not ingress. Okay, so this is a kind of security mechanism where you isolate by putting certain resources in public subnet and certain resources in private subnet. So that's what you can see, and you can also see that the address space that was given to the VPC has also been broken down. It's been split up into four parts. Okay, I will give you a short explanation of how this cider block works. Okay, so take that you have, this is your cider block. Okay, this looks like a typical IP address if you see, and this is known as a subnet mask, the /16. Now, these four parts are actually four groups. You see, four groups of 8 bits each. Okay, so there are four groups of 8 bits each. So totally you can see it's about 32 bits, right? So when I give a subnet mask of 16, what I'm exactly saying is the first 16 bits, that is 10.0, is locked. Okay, so this is your network address. Okay, so this is locked, the first 16 bit. The remaining 16 bits, that is this portion, this is still flexible, and this is where your host address comes in. So if you go to see, they are of 8 bits. So the starting address will be 10.10.0.0, and the last one will go up to 10.0.255, right? And now if I come back over here, you can see that we have split up our VPC cider block into subnets. And you can see a /24 over here. So what does that mean now? So when I say /24, basically we are making it smaller, right? So say if I say 24, we are locking 24 bits. So these bits are locked. Okay, and I think one of the subnets had 1, if I'm not wrong. The other one was 10.0.2.0. Okay, so you can see that the first 3 parts are locked, and the variable part is only this. Okay, so it's inversely proportional. The larger the subnet part, the lesser number of IP address. Okay, so I hope that part is clear. So this is how we split up the subnet. All right, so that's out of the way. Now, another thing I want to clarify is that people think you can just have one VPC. As I mentioned, you can have more than one VPC. So you can have up to 5. Okay, so there could be multiple VPCs. You would want to isolate the VPCs based on your workloads, based on the environment that you're working on. And there are means of communication between the VPCs as well, which I'll tell you later about. Now, let me take you to the part that I have actually called it public subnet and private subnet. me calling it public subnet and private subnet doesn't make it public or private. Because if you see technically, it still doesn't know how to talk to the external world. Okay, when I
Mm-hmm.
say external world, it is the internet.
Yeah.
There needs to be a doorway, right? So if we are in a house, how do I get to the outside world? I need a doorway. So
Mm-hmm.
that's where you see the internet gateway comes into the picture. Okay,
Mm-hmm.
so the internet gateway is a network construct that we need to attach to our
Mm-hmm.
VPC, and that's how it is the door to the external world or the internet.
Mm-hmm.
Still, if you go to see, after I've attached the internet gateway, my resources which are residing in the so-called public subnet still do not know how to reach outside. They don't know the way to the door.
Mm-hmm.
Who's going to show this path? That's where our route tables come into the picture. Okay,
Mm-hmm.
so we need a route table, and these route tables will have route entries. Now, if you see, as soon as you create your VPC, as soon as you create it, there is a route entry, which is a local route entry, which is already present there, which means
Mm-hmm.
that all the resources within this address space, that is 10.0.0.0/16, they can talk to each other. That's called as local route. So they can
Mm-hmm.
talk to each other privately. However, my resources A and B or my instances E and F still don't know how to talk to the internet. So how
Mm-hmm.
do we let them know that? We have to tell them, please go via the IGW or the internet gateway. So we need to add a route. Okay, so we are telling them, if you go to see, this particular CIDR block is encompassing the entire internet. Think about it. It
Mm-hmm.
is all the addresses in the IPv4 range. Okay,
Mm-hmm.
so we are saying, if I need to go to the internet, please go via the internet gateway. Now, technically, it has become a public subnet, and my
Mm-hmm.
public resources can talk to that. Hope that's clear.
Mm-hmm. That's fine. Yeah. So, but how do these private subnets? I see there's also another route table, right? It looks like
Hmm.
they go somewhere else to a NAT gateway. But once they are in a NAT gateway, they can go
Hmm.
outside as well, right? Or how does this work?
Yeah, let me just explain that part as well. So you're right, sometimes our resources which are residing in our private subnet also
Mm-hmm.
need to talk to the internet. They may not welcome incoming or ingress, what we call, but it might want to talk to the internet, for example, to pull down patches from the
Mm-hmm.
internet. But how would it do that? So your question is absolutely correct. How will it know how to go out, right?
Mm-hmm.
So that's where we have another route table over here. So we attach route tables to each subnet. Okay,
Mm-hmm.
and we customize the entries in the route table based on the route the resources will be able to take to different networks.
Mm-hmm.
So we will also attach one route table to the private subnet, and if you notice over here, it automatically inherits the local route. So the local
Mm-hmm.
route is automatically inherited. That will always be there. So they will be able to talk internally to each other.
Mm-hmm.
However, to talk to the internet, it cannot, or it should not reach out to the internet gateway. So what do we have here? You can see here we have something called as the NAT gateway.
Mm-hmm.
So a NAT gateway is a managed service. It is a networking service that is provided and managed by AWS. It is highly available, scalable, and redundant. So you don't
Mm-hmm.
have to manage the infrastructure. It will automatically do something called as NATing, that is
Mm-hmm.
network address translation. So what does
Mm-hmm.
that mean? So these resources over here do not have public IP addresses. They have only private IP addresses. So the NAT gateway is actually going to translate this private IP addresses to public. So when a request is going out, it will go via the NAT, and the
Mm-hmm.
NAT will go via the internet gateway, because you can see there is a route over here, and that's how it's going to go out.
Mm-hmm.
Similarly, when it's going to be coming in, it is going to translate and understand which particular private instance to go back to. So it is like an
Mm-hmm.
intermediate party that is sitting there doing the network address translation and
Mm-hmm.
securing your private resources. Hope that
Okay.
makes sense.
That makes sense, which brings me but to the next question. So
Hmm.
you said the VPC is like a plot of land, right? Usually
Mhm.
I have a fence around my plot of land. So
Yes.
if my colleagues have or my teams have their own VPC, which is also obviously surrounded by a fence, how does this work then? I assume that they are not local to me, right? Because they're on a different plot of land, similar to my on-premise data center. We still have workloads there.
Yeah.
So how can I make these things that are not part of my land talk to each other in a secure way?
Absolutely. So great question. So of course, till now we've just given them directions and the route to move around between different parts of the VPC as well
Mm-hmm.
as the internet. But how do we control that movement of packets? We might
Mm-hmm.
want to block some packets. We might want to welcome some packets. So that's where we have NACLs come into the picture. So
Mm-hmm.
NACLs, Network Access Control Lists, these are a list of rules which are at the subnet level. So you'll see there is a NACL associated with every subnet. Okay.
Mm-hmm.
So the same NACL may be associated with multiple subnets, but each subnet must have one NACL. Okay.
Mm-hmm.
Now these are set of rules which control incoming as well as outgoing traffic.
Mm-hmm.
Now, there is something called as a default NACL. So, when you set up your subnets, when you create your subnets, there's a default NACL which is already created for you. Now,
Mm-hmm.
these NACLs allow everything incoming and everything outgoing. So, that's the default case.
Mm-hmm.
Of course, you will most likely want to secure your boundary. You would want to secure a house and your fence, and you want to allow only certain people in, right?
Yeah.
So that's where your rules come in. That's where customization of your knuckles come in. You're going to create custom rules.
Mm-hmm.
So when you create your custom rules, you'll see there is an option of either allowing certain traffic or blocking certain traffic, and you can go very granular. You can choose the type of protocol. You can choose the range of IP addresses from where you want to welcome traffic or where you want to block to. So I'll show that to you as well in my
Mm-hmm.
demo. But I'll show you another virtual firewall apart from NACL also. So this is
Mm-hmm.
protecting you at the perimeter level, at the subnet level.
Mm-hmm.
There is another one that is called as security group. Okay, all right, you've gotten traffic coming in, you have blocked certain traffic going out, but how do you control traffic incoming and outgoing from your EC2 instances or your
Mm-hmm.
compute instances which are there in the subnet? That's where you have security groups. Now, just like NACL, security groups also have a default configuration. The default configuration is such that it blocks anything incoming but
Mm-hmm.
allows everything outgoing. It's just like your doorkeeper.
Mm-hmm.
When there is guests coming into your house, they will stop you on the way and ask you who do you want to visit, or they'll ask you to enter into a register, etc.
Mm-hmm.
But when you're leaving, that time they won't really bother. Okay, so these are also called as stateful firewalls because they remember you. In case of NACL, sorry, not NACL,
Mm-hmm.
these are stateless, so there's a check which happens both way. Okay,
Mm-hmm.
so this is basically your security layers, and I will show that to you even in the demo. So
Mm-hmm.
probably we'll have a look, and let me show you a little bit of some differentiation as well.
Mm-hmm.
So just to reiterate, so people tend to get really confused, right,
Yeah.
between security groups and NACLs. So your security groups are at the instance level, or
Mm-hmm.
really speaking, it's at the ENI. So that's your elastic network interface level. That is actually
Mm-hmm.
the doorway in and out of your instance,
Mm-hmm.
whereas your NACLs are at the subnet level.
Mm-hmm.
As I said, security groups are stateful. It remembers you. Okay, so once you've been let in, when you've been allowed, if you set up a rule to allow a certain kind of traffic, then
Mm-hmm.
it will automatically let you go out. Okay,
Mm-hmm.
so that's stateful. And stateless is in case of NACL because there's a check happening both ways. Okay, so
Mm-hmm.
incoming as well as outgoing. So these are a few things that you need to remember. Also, when you're setting it up, most people I've seen have a brilliant workload all set up, but they are wondering why aren't they receiving traffic, and they look
Mm-hmm.
at their VPC flow logs, which is one place where you can do some kind of troubleshooting, and you'll realize that all your incoming requests are getting blocked. So
Mm-hmm.
there's something blocking it. Possibly you have misconfigured your security group, or probably there's something blocking it at the NACL level, or possibly you didn't even add a rule into your security group. So remember,
Mm-hmm.
by default, everything is blocked in
Okay.
security. Okay, so this is something that will help you understand the differences. And of course, I'm going to share this with you, and you can look over it again. Okay,
Mm-hmm.
So
Sounds good.
do you want me to go to the demo now? Will
Yes,
that help?
that would be good, so I can see it on the living object.
Definitely. All right. So just in the interest of time, what I've done is I have gone and created a VPC and kept, but I'm going
Mm-hmm,
to show you how a VPC is built. Of course, you
mm-hmm,
can go and use the default VPC. Like I said, this is the default one. And how do you differentiate between them? You can see it says yes. So you
mm-hmm,
quickly want to start a blog site of yours, and you don't want to be bothered about setting up the VPC, you can go ahead and use that, okay, for
mm-hmm,
experimental purpose. But it is better that you create your own customized VPC. So I've got one
mm-hmm.
created, but I'll just quickly show you how to create one. I hope my screen is visible and you're able to see the
Yeah.
console. Yeah. All right. So you can see over here, there are two options. One is the finely granular option where if I choose VPC only, I have to literally go step by step where I showed you. You create the VPC, you create the subnets, you have to create the route tables, you have to
Mm-hmm,
attach the internet gateway, you have to attach the NAT gateway if you need it. So you do everything one by one. Or if you're super lazy or you want to do this quick, which I'll show you, you can use the wizard. Okay, so
mm-hmm,
this wizard over here will visually show you the flow as well. Okay, so there are some standard configurations by default it has done over here. So
mm-hmm,
let me just give it another name. I just keep it Pesa. You need to assign a cider block. Like I said, this is the address space. You can change it as well. I can
mm-hmm,
go and change this. That's fine. Okay, so you can choose IPv4 or IPv6. That's up to you. You can choose how many availability zones you need. So this is
mm-hmm,
Northern Virginia, which has three availability zones. So you can opt between one, two, or three.
mm-hmm.
Within those availability zones, how many public subnets? So remember, you don't always have to have a public subnet, because what if your workload is such that doesn't require internet exposure? So that's why you
Mm-hmm,
see a zero. It could be zero as well.
mm-hmm,
And then you can choose the number of private subnet as well. Okay, so this has
mm-hmm,
two, two, and two, and you can see over here the visual representation. So this
mm-hmm,
is what it is going to make. So you can easily visualize what it's ultimately going to make. It's going to
mm-hmm,
make a VPC. It is going to be using, you've not given preferences of availability zones, so it's picked
mm-hmm.
1A and 1B. The last character is an indication of the availability zone. So there's A, B, and C. So it's
Mm-hmm.
picking these two. And you can see over here, the green one is the public subnet in each of them.
Mhm,
And this is the private.
mhm,
How will it reach out? Because I've said they are public, so obviously it needs to talk to the internet gateway. So it's also going to create an internet gateway for me, and the route to the internet gateway is via this public route table. Can you see over here? It's showing you
yeah.
the path also. So both of them are sharing the same route table, so they don't really need a separate route table.
Mhm,
However, if you see in the private subnets, they have separate route tables. This is for this one, and
mhm,
this is for the US East 1B1. Okay, and um, okay, so I'll just remove the VPC endpoint part. That we'll talk about that later. I'll say none. Okay,
mhm,
now currently there is no NAT gateway. Now, if I say that I want a NAT gateway, and as a best practice, you should have one NAT gateway per AZ. That is for a
mhm.
highly available architecture. Remember, if you just have one in one availability, then what happens if the AZ goes down, right?
Yeah.
So you can see over here, the route table will have an entry, and this is the way the traffic will go out via this. So this
Mhm,
is what it is going to visually make. So I
mhm,
have created it already. So I will go back and show you what's already made. So this is how I created it.
mhm,
And once it's created as well, you can have a look at the visual part of it. So this is the one that I made. And you can see over here, okay, this is what it's created. The
mhm,
same thing I have, just for simplicity, I've chosen only one availability zone. Okay,
mhm,
and the public. So now I can open this. Okay, so because I've already created it, I'll show this to you. So if I open this up, okay, you will see it over here also. Okay, so you can see there is a private and a public subnet
mhm,
which I've created, and which VPC are they associated with, you can
mhm,
see. these two VPCs. So I created it from the wizard, but I could have created a subnet from here as well. So
Mm-hmm.
I could have later selected the VPC. So I could have said that, say, now I need one more subnet. So I'll say this one. I'll come in here and I'll give it some name, say subnet. I'll just call it something extra. And previously there was no preference, but I can be
Mm-hmm.
very specific and I can name the availability zone where I want it created as well. So this is
Mm-hmm.
how I can create it at a later time, but I have already done that. Now
Mm-hmm.
another thing I want to show you is there were these two route tables also which were created. Okay, so uh, if you remember, there is a public route table. See this
Mm-hmm.
one which is created, which is associated with the subnet. Okay,
Mm-hmm.
so if I would have done all the steps on my own, I would actually have to do that association as well. But this is already done. You can see, and you
Mm-hmm.
can see there is a local route, so everybody
Mm-hmm.
can talk within the subnet, and within the public subnet, if they want to reach out to the internet, they will go
Mm-hmm.
through the internet gateway. So this was
Mm-hmm.
also created for me, and I show that to you over here. So this is the ID of the internet gateway. You will see it
Mm-hmm.
in this list. Okay,
Mm-hmm.
so this is your internet gateway, and you can see it is showing as attached.
Mm-hmm.
Attached to whom? It is attached to that VPC. Okay, so if I would
Mm-hmm.
have individually created that internet gateway, it wouldn't have been attached. So if I just do a test IGW right now in front of you,
Mm-hmm.
you will see that it will be in unattached state. Okay,
Mm-hmm.
so if you see over here, the one I
Oh
just
yeah.
created, it is detached. So I actually have to go and attach, and I need to do these steps on my own. But because
Mm-hmm.
I opted for the wizard way, so it automatically did that for me. Okay,
Mm-hmm.
so
So if, let's say, one of my people says, "Oh, the internet is down," chances are the internet might not be down. Someone just detached my
right,
internet gateway.
of course, and plus the other reason, it could be in detach mode, or maybe there is
Mm-hmm.
no route. So I just now showed
Okay.
you. So what if the route itself is missing? Okay,
Mm-hmm.
so somebody went and deleted this route, so your
Mm-hmm.
resources don't really know the path to go to the internet. So that's also
Mm-hmm.
important. You need to check over here as well.
Mm-hmm.
Okay, so this is for my public subnet. Now
Mm-hmm.
I have another subnet that I had created. If you remember, that was my private subnet. Now for my resources within my private subnet, I don't want them to talk directly to the internet. I want
Mm-hmm.
them to talk via the NAT gateway. So there was a
Mm-hmm.
NAT gateway created. Okay, I'll show you the
Mm-hmm.
NAT gateway. It's created over here. Okay, you can see
Mm-hmm.
there's a NAT gateway created.
Mm-hmm.
It's in the public subnet, and it is actually assigned a elastic IP address. And elastic
Mm-hmm.
IP address is a static public IP address, by the way.
Mm-hmm.
Okay, so it's attached that, so it's here, and the same thing you can see here. So basically, what the private subnet knows is that if I want to reach out to the internet to pull down some
Mm-hmm.
patches, I need to go via the NAT, and this is the ID of that same NAT. If you remember
Mm-hmm.
D2F, this is the same one that I'm showing you over here.
Yep.
All right, makes sense.
Yep. All good.
All right. So yeah, so this is the entire thing. And yes, of course, then once you have your address space, your VPC in place, that's when you then start provisioning or launching your EC2 instances in them.
Mm-hmm. Okay. Super. So, and then I saw earlier in the demo you declicked something. It says VPC peering, I think. What is this all
Okay.
about? Why did we not VPC peer?
All right. So obviously that there are, let me just show you some
Mm-hmm.
minute. Yep. All right. So we have multiple VPCs. Like I said, you
Mm-hmm.
could have multiple VPCs within the region. We could have other VPCs in other regions within the same account, or
Mm-hmm.
you might be having multiple VPCs, right, in your other
Mm-hmm.
accounts for your different workloads. Now, what if you have like a shared resources VPC that all VPCs want to talk to, or you want two VPCs to talk to each other? How
Mm-hmm.
would you be able to do that, right? Because this is a
Mm-hmm.
private address space. So that's where VPC peering will help you. So
Mm-hmm.
VPC peering is another networking construct which is
Mm-hmm.
highly available and scalable, and this is also maintained by AWS. So it is really simple to set up. It is a one-to-one connectivity. It's not one-to-many, it's one-to-one. And a requirement is that the CIDR blocks should not overlap. Okay, so these are some requirements. All you need to do is go and make changes in the route table. Okay, so you can see over here, this is the CIDR block, the 10.00/16. You just need to make an entry into the route table of the initiating VPC over here, and you are basically saying go via my peering connection. Similarly, over here, you can see that it needs to talk to VPC A, if you call it A, and this is the CIDR block. And we are also saying if I need to talk to this, go via the peering connection. This is what it means. And it's as simple as that. But there are certain limitations of VPC peering. The number of VPC peering connections that one VPC can have, that's limited. So that's why we have other networking constructs also, which I'll tell you about. And remember one thing, that transitive peering is not allowed. What do I mean by that? So say VPC A talks to B and B talks to C. That doesn't imply A can talk to C directly. Okay.
Okay.
So there is no indirect talking. A has to have a peering connection with C in order to talk. Okay.
So I
that's
can't have
how
a proxy in between, so to say.
no.
Okay.
So you
That
have
sounds
to
good.
have a peering connection between them. And it's not that you can directly go and start peering with any VPC. There is a request, a peering request which goes out. Say VPC A will send a request to B and B has to accept it or reject it. If it accepts it, then they can start talking, provided you make these routing table entries as well.
Okay.
Okay.
Super.
All right. Hope that helps.
Yes.
Okay.
And then you mentioned you had some other connectivities in case that VPC peering is not, suitable. So I assume, is it suitable for me to use VPC peering for my on-premise workloads, or is it just peering within the AWS cloud?
So there are multiple options. Let me just show you, starting with the very basic option that we have. Okay, so the most basic option that we have is where we can have a site-to-site VPN connection between our VPC as well as our on-premises or our branch office or our data center. We can have it via a site-to-site VPN, which is ultimately using the public internet. Remember that it is a private tunnel that is going through, and there are actually two tunnels, but there is a speed limitation or bandwidth limitation of 1.25 gbps. So you need to be aware of that. If you are okay with that, then that will suit you. And if you have intermittent data that you're supplying back and forth, then it's all right. But if you want a very consistent bandwidth, like 10 100 gbps, and you have a whole lot of data moving back and forth, probably you should go for something called as a direct connect connection, which is actually a dedicated fiber optic lines that is set up for you, and it is connected to a central location which is called as direct connect location, which is maintained by some of our partners. So you can check out with these partners. However, remember that setting up a site to site VPN connection happens like that within minutes. It's quite simple to do. However, if you want to go for direct connect, then you will have to sign letter of agreements. It could take up to days and weeks also at times. Okay, but there are subtle differences between the two. Certain organizations have both of them, right? Just for you can take it as a disaster recovery solution, because just in case your internet is down, because your site to site VPN is dependent upon the internet, you still have the direct connectivity. So these are the two options that are there. Obviously, you can have a mixture of options also. So I'll just show you. There are some other options available as well. So you can combine direct connect and site to site VPN as well, as you can see over here, because site to site VPN, your data is encrypted in transit by IPsec. Okay. However, in direct connect, there is no security. It's not encrypted. So you might want to have the best of both worlds. So you can have a connectivity mechanism like this. So say right from your on premises, from your customer side, you have a direct connect over here, and then from your direct connect location onto your VPC, you can have a site to site VPN connection with your protected traffic. So I will not go too much into depth, but I'll probably share this link, and you can see there are many different configurations you can mix and match and have.
Sounds
All right.
good. Yeah,
Yeah.
perfect. Good. So, yeah, now we've talked about the VPC a little bit, and I have now a good understanding how I can build what I used to have in my data center in the cloud. But now we need to go into the more nitty gritty, right? So once I've built it all, obviously I need to have these EC2 instances running my workload, and I'm a little bit concerned. Maybe I'm getting this wrong, but they're virtualized servers, kind of, right? It means that other people live on the physical machine as well in some shape or form. But we have a couple of workloads where the regulator said it needs to be on my hardware, in the sense of it's only my company that lives on the hardware. Is
Okay.
is there a way you can help me with that? Because I assume I cannot bring my own server into your data center.
Absolutely, there are definitely ways. So let me just start with how it actually works, how virtualization works in our AWS data centers. We have bare metal servers; those are the physical hosts on which. So usually, what would you have? You would have the hypervisor, which is the software which is managing your virtual machines. So your EC2 instances is actually a virtual machine by itself. So if you see, the standard virtual machine will have a operating system, a guest operating system, and it will have some applications running on it. On our side also of AWS, the host, the hardware as well as the hypervisor are combined together to form a system called as Nitro system. So it's a lightweight hypervisor which is highly secure, and on top of that you have your EC2 instances running. So by default, it is a shared tenancy, like you correctly said that you don't prefer shared tenancy. Now these EC2 instances that we have can belong to multiple customers. Of course, they're isolated from each other and they're secure, but you might have some compliance reasons within your organization, like you mentioned, where you do not want to share the space or the underlying host with other instances for other customers. So the options that we have in that case is we have something called as dedicated instances, and we have dedicated host. Now, what is dedicated instances? So basically, what you are telling AWS is that I do not want instances of another customer on the same hardware host. Only my instances should be running there. Okay, so it is just like, you say, if you're renting out a house, and in a general case, you would probably share it with your friends. So that's
Yeah.
your shared tenancy. But when you're saying dedicated instance, you're saying I'm going to share it only with my siblings and my relatives, not with any outsiders. So what happens over here is you have a dedicated host to yourself. You do not have granular level control and administration of the underlying host, but the host is dedicated to you only. So that's dedicated instances. So that's one option that you have. That is more expensive than your shared tenancy, obviously. And the third option is dedicated host. Now, dedicated host, just like the name says, the actual physical server is dedicated to you. Now, this will be the case where you are bringing in licenses and you have like a per core, per socket level license, and you need that connectivity, you need that control over that physical host. You cannot lose it. When you stop the instance, you don't require the instance to go and start off somewhere else, right?
Yeah.
In that case, you would go for a dedicated host, and that will solve this problem of yours. Of course, that is the most expensive of the lot, but you have that choice. So for example, now if I take you to the part where I can launch an EC2 instance, I'll point you out exactly to the part where we can make this choice. Okay, so there is an option. I'll go through the other features for configuration also, but I'll show this part to you where you can choose. Okay, so you have tenancy over here. So by default, the tenancy is shared. Okay, so this is the default. If you want it to be on dedicated instance, then you'll have to go for this, else you can go for dedicated host.
Okay.
Make sense?
Yeah, sounds good.
Yeah.
So one problem solved, another one to go. So as you could see, our very furry IT manager was
Uh-huh.
crossing our path here. And we have had a little problem this morning. So one of my team members, he's very cost conscious, right? I like it,
Okay.
don't get me wrong. But whenever he sees something running that is not being used, he has this habit of just saying terminate instance. So we had some cases where other team members had data on those instances that was actually data we should have kept in some shape or form.
Hmm.
And I know it's our fault, best practices and all that. Some of those instances were shut down and we lost all of the data. I know there must be some way of keeping this data even after you shut down the instance, but we have no idea how to do this. And ideally, I don't want to lose any more data because
Definitely, yeah.
some people
Data is
were very
gold.
upset.
Of course, definitely. Yeah, so I can imagine the outcry. But let me tell you how uh, things work. Just give
Mhm,
me a moment. So, okay. So obviously you have your EC2 setup. I will
mhm,
go back and answer any questions you have related to the configuration. But let me just
mhm,
answer this part about storage, right? So obviously I am assuming that y'all were using instant store. Okay. So if you see
mhm,
over here, there is something called as instant store. Instant store is actually a local storage which is directly connected to the host on which your EC2 instance is running. So
mhm,
what happens is it is a ephemeral or a temporary store. What do I mean by that? So when you stop an instance, remember next time you start an instance, it may be launched on another host. So what
mhm,
happens is this direct connectivity is gone. So that's the reason you are losing the data. Okay, so
mhm,
if you want to persist data, the data that you are using, you want it to keep it for long term, then this is not the right choice for you.
mhm,
Instant store should be only used for temporary purposes, for swap space, etc. So it is very
mhm,
fast because you can see it's like a direct attachment. So it will give you very high IOPS and very low latency. However, for data that needs to persist for long
mhm,
term, this is not the good choice. What you
mhm,
should instead do is you should opt for EBS volumes or elastic block store. Okay, so
mhm,
this is a type of storage that you have. So if you can identify with raw storage, how we have our hard disk or SAN storage area network, it's something like
mhm.
that. Now it is connected over the network, as you can see,
Yeah.
right? Now, as it's connected over the network, the life of your EBS volumes uh, persists beyond the life of an EC2 instance. What do I mean by that
Mhm,
is, even though your EC2 instance crashes or stops,
mhm,
you can detach it from here and go and attach it to another instance, and the data will not be lost.
mhm,
Okay, so you can attach and detach it because it's a network attached storage, and the
mhm,
data will persist on it. You can take backups from it using a mechanism called as snapshots. So
mhm,
snapshots is a mechanism of backing up, which is like a incremental backup mechanism. So
mhm,
every time you take a snapshot, only the data that has changed, it will keep track of that. So in turn, it is reducing the amount of storage also, so you pay less,
mhm,
because ultimately those snapshots are getting stored in some S3 bucket somewhere, right?
mhm.
So that is a backup mechanism that is there even for EBS. You can
Yeah.
also have something called as a data lifecycle manager,
Mhm,
which you can configure, and it can periodically maintain the life cycle of these snapshots also. Maybe you don't
mhm,
want to retain them for a long time, you want to expire them or delete them, you can do that,
mhm,
or you can schedule taking the snapshots. So EBS would be the right choice for you to persist your data. And
mhm,
within EBS also, it's not that you just have one size fits all. We have different types of EBS volumes, okay,
mhm,
depending upon your use case. So if your use case is where performance for you is measured in terms of IOPS, you're reading and writing a lot. So
yeah.
you're going to run a database. So I'm assuming you will be running databases or enterprise applications. I would
Mhm,
suggest that go for your general purpose one if it's a small, medium sized database,
mhm,
or if you are running a highly performant database, NoSQL database, enterprise
mhm,
application where IOPS, the number of reads and writes per second, needs to
mhm,
really be very large, more than 16,000. Okay, so general purpose ones can go up to 16,000 IOPS.
Mhm.
Provisioned IOPS can go beyond 16,000 as well. Okay,
Mhm.
and these are all SSD based. So you know that if it's SSD based, it's going to be really fast.
Yeah.
However, it's not always that you will prefer IOPS. Sometimes
Mhm.
throughput is very important to you. Throughput is the amount of data that you're reading and writing is a
Mhm.
lot sequentially. That time you can go for the HDD based ones. Okay, so
Mhm.
over here you have high throughput. So if you're continuously writing a lot of data, then you can go for the throughput optimized one. Or
Mhm.
cold cold HDD implies you are writing a lot of data but infrequently. Okay, so this is like
Mhm.
a cold storage, so you can go for this one. So based on your use case, you would want to use this. And you can see over here, uh, if you go to this page over here, the volume types, you can see the differentiation between them.
Oh.
Even the use cases are mentioned. Okay, so if you look at
Mhm.
the use cases, you can see what are they suited for. So traditionally for medium sized databases, here you can say more than 64,000 IOPS, right?
Mhm.
These are your SSD based ones, and this is your HDD based volumes. Here you
Mhm.
can see this is for your big data, log processing, right? So there are two
Mhm.
types. Okay, so you need to pick the EBS volume also based on what kind of workload you need.
Mhm.
Make sense?
Sounds good. Sounds
Yeah.
good. And as we are at storage, so obviously we're big fans of S3, right? It's brilliant. You just put something in a bucket and you don't need to worry about it.
Mm-hmm.
But as I said, our best practices are not that great. So we're just using the normal kind of S3 bucket.
Mm-hmm.
And we decided we have a shared bucket across teams, right?
Mm.
But so as it happened, someone by accident deleted an object because they thought, oh, we no longer need it. And they weren't aware that this is not like your mobile phone where you delete something and then you can go back to this kind of, backup rubbish bin and retrieve it. It was gone.
Right. Yeah.
So
Yeah.
it was not his own object. It was the colleague's object that went missing. And
Hmm.
again, we had a big drama, not as big as the EC2 instance drama, but it was considerable. And they didn't speak to each other for some time. But so is there a way other than just saying each of you gets their own bucket to make sure that people can't access certain objects, and that we also kind of have an option of if someone accidentally deletes something, that it's not gone, but maybe kept somewhere and can be retrieved? Because as I said, we have no idea. We just put stuff into this bucket and then people help themselves to whatever object they need. But I don't think it's a very good setup because we had some problems.
Right. I get what you're saying. So so once you create your S3 bucket, and I'm assuming you'll have a static website which is set up,
Yes,
right?
that's also in there. So everything is in there, including the static website. And it's a
Right. Right.
public bucket, which again
Hmm.
is a complete different problem. We can dive into this in a second potentially, because I get these alarm emails that said, oh, a bucket is wide open to the world.
Hmm.
And they're not great emails. They come from our
Right.
CISO department.
All right. So essentially, there are many ways in which you can control access to S3. S3 is simple storage service, and it is a object type of storage. So EBS,
Mhm,
what we were talking about earlier, is block storage. So in
mhm,
block storage, your data is divided into blocks. But in case of S3, your object is a blob of bytes. So
mhm,
every time you're writing data, it overwrites the entire object. Okay, so that can be
mhm,
really risky. Like you're saying, somebody goes and deletes it, that could be a big problem. So
mhm,
ideally, what you should be doing is, so if you have, say, uh, a bucket over here, you should be turning on something called as versioning, right?
mhm,
So when you turn on versioning, what happens is every time you write to a object, or you
mhm,
write to so every object has a key, right? So for
mhm,
example, over here you can see I have a object in this bucket called as River City. I hope you can see that.
mhm,
And if I open it up, it has its identifier is based
mhm,
on its key. right? So if I go and you talk to S3 over the web, over the internet, and this is the object URL. So if you go and put that object, that is, it is actually going to replace that entire object. So it could be really risky, right? So if you have a text file there and you've just put a full stop there and you go and upload it, it's completely going to replace it. So what you can do is you cannot recover once you've gone and deleted it, overwritten it. You should ideally be turning on your versioning. Okay. So there is an option over here called versioning. So when you create a bucket, by default, versioning is turned off by AWS. Now it is turned off, as you can see, it is disabled by default. The reason being, if you turn on versioning, every time you go and upload the object with the same key, it is going to make another version of it. So say the first version was of 1 GB, the second one is of 2 GB. So in total, you are going to be storing 1 plus 2, 3 GB. You're going to be paying for that. And accidentally, if you've done that, you will be wondering, why am I paying so much, right? Because there's so many versions. If you're going to have millions of objects, you can imagine. However, in the cases where you have critical data, like you mentioned, and you want to revert back to a previous version which you accidentally delete, then you can do that if you have versioning enabled. Okay, so if you go ahead and enable it, okay, so remember that you can enable versioning, but once you've enabled it, the next time you cannot stop versioning, you will just disable it, meaning what has happened before, the versioned objects will remain. That point onwards, the other objects will not be versioned. Okay, so remember, you cannot get rid of what had been versioned before. Now, what advantage versioning will give you is that every time you go to delete a versioned object, it is going to store a delete flag against it. This is like your recycle bin. It is not exactly wiping it out. So you can go and remove the delete flag and it will be restored back again. Okay, so so for example, if I just enable this, okay, and you'll see over here, say I'll go and upload a file, and okay, so I'm just going to upload this file over here, right? And let me just open this file. So currently it just shows demo file with some data, okay, and then I'll say some more data, and I'll save this, and then I'll upload it again. Okay, so now I'll go back here. So I still have the original file here, and if I go to upload again, and let me go and okay, and I'll upload it again. Okay, and let me go and show me the versions, and you can see over here, these are the version IDs, right? So now if I go and delete this, okay, right, okay, so over here it seems as if it's gone, but you can restore it because it's a versioned object and we have the versioning over there. Okay, so what I'm trying to say is you should be actually versioning your object. That's one way to do it. There is something called as object lock also. Okay, so over here, uh, okay, there's an option called as object lock. So when you put on an object lock, this is meant for worm model. So meaning write once, read many times. So basically you're going to be writing it many times. Sorry, you're going to be reading it many times, writing it only once. So in that case, ideally, if you put in an object lock, that's also going to stop you from deleting. And there's another option called as MFA delete. Okay, so MFA delete, you cannot set it up from the console. You'll have to do it from the command line or through your SDKs. So if you set up MFA delete, so there'll be two checks, not only your access credentials that is going to check, also it's going to have the second level of check with your MFA device that you have, and then
Mhm.
only it will allow. So these are three ways. And of course you have other things also, like your bucket policies, which is your
Mhm.
resource based policies, which you can
Mhm.
have at the bucket level. So you can set up your permissions over here.
Mhm.
Okay, so you, right now I don't have a policy over here, but you can go in and set up a policy here. Or for your IAM users, the users
Mhm.
of your AWS account, you can set up permissions which will allow them only read permissions, right? So if you have
Mhm.
a IAM user and you give them only read permission, they will not be able to overwrite it or delete it. Okay, so those are
Okay.
some of the mechanisms that you can have.
Mhm.
Okay, so I think that is for your first question. You had also asked me that how do I protect my public bucket? Okay, so now,
Exactly,
yeah,
exactly. Because we have this thing, we were told, we found out in
yeah,
the documentation that if I want to host a static website,
hmm,
the S3 bucket needs to be public. But our
right,
CISO team said there are no public buckets in this
hmm,
company. So whenever someone has a website and uses a bucket, we get this email, all of us, in the middle of the night saying this bucket is public, it needs to be shut down. But how do we do this?
okay. So you can see over here when you create a bucket, your public access is turned on, public block access. But because
Mhm.
this is a public website, I have turned it off, and you can see my bucket policy is allowing everybody from the internet to go and read. So this is a
Mhm.
read action. Okay, so
Mhm.
I'm allowing everybody. The principle is who can read. So this is technically anybody can reach to this bucket directly. But I think
Mhm.
what you would want is you don't want anybody to reach directly. So what we can
Yeah.
do is we can have something called as cloud front in front of S3, and cloud front could actually allow HTTPS requests. So you can have your SSL certificates also assigned, because to your cloud front you can also have a WAF, what is the web
Mhm.
application firewall. That's going to be an additional protection for your S3. And the main
Mhm.
protection is that nobody can reach your S3 directly. So they will have to go through CloudFront. And
Mhm.
CloudFront, you can set up something called as object access control. Okay, so these
Mhm.
are like permissions that we give to CloudFront to
Mhm.
only access S3. And so you as a user externally will have to reach for the CloudFront endpoint and not for the
Mhm.
S3 endpoint directly. So basically, you will not be talking to this the website endpoint which you see over here.
Yeah.
You see there is a website, and so you won't be directly talking to this is
Mhm.
my HTTP endpoint. Okay,
Mhm.
you could probably have a HTTPS, a secure endpoint of CloudFront that you will be talking to. And
Mhm.
CloudFront, as I said, only has permission which is called as object access control permission to talk to S3. So that is one way that you can protect your S3 bucket, and your bucket need not be public that time. Okay, so I do not need to keep it public like I showed you earlier. Over
Mhm.
here it was public, but I can block that off.
Perfect. Thank you. Good. And I see Ashish has miraculously appeared again. We're out of time, but we
Okay,
nearly managed to get through everything.
all right. So that's great. I hope I've been able to help you.
Yeah, I mean, so I play a role of scarecrow. So when there is birds on the field, I have to be there so that we know the timing. And this title is given to me by Sharik. Sorry, I forgot to add Sharik and other people on stage, so I'll quickly add them. So Sharik is here. Then we have Kapil who is responding to chat. Prasad is here too. So thanks everyone. Hopefully you have learned something. And Sharik, Prasad, and Kapil are helping so much with the backstage thing. So please ask question. We will answer as much as we can. And I'm creating 1 minute series where I would try to answer other questions also. So we'll go through some more things, and probably you have picked up bits and pieces of how you learn about things and how you explain it to customer. I will take 10 minutes to explain few things in analogy, and then Prasad would take over and he would explain that how these conversation can help you in learning the behavioral skill. So he has just prepared a slide deck. We'll go through that. And thanks Sharik and Kapil. We'll add you to stage at the end. Let me remove it everyone, and I'll share my screen to get started. If anyone has any question, keep on putting that into chat. Thanks, Nicole. Thanks, Parna. Nice discussion and lots of things to cover. I was sure that there was so many things you could not cover because of time. But yeah, we would add this slide deck to the resources section, and everyone should be able to then move forward with it. So please keep your mails checked so that we can send this information to you. Thank you, Nicole. Thanks, Parna. I'll now quickly talk about some of the analogies to help you better. Why I prefer analogies? Because I'm able to make the connection and I'm able to retain that knowledge for a longer period. That's why I prefer analogies. I will quickly talk about few analogies and I will share the link where you can go in detail of it. A lot of people may know about the networking in physical world. So let's say if you have physical servers and you want to connect to this physical server, how the component looks like and how it works in AWS field, let me explain that. So physical server would require connectivity through LAN card that would connect to network switches. Network switches would be then having multiple switches connected together so that we can expand the network. Probably we would need VLANs in that so that we can create logical isolation, and then we would need router through which our communication can happen between VLAN. And when we are moving forward, we want to connect to internet, and that's where we would create firewall based solution, and we would have an internet router who would connect us to internet. This is how a typical physical network works. Let's see what else happens into AWS world. So AWS is not changing the fundamental way we work. We are still keeping the same concepts alive, but we have implemented it in little different manner. So I'll explain you that what different manner we have implemented it, what options are available in AWS. So we do not give you physical servers directly, we give you EC2 machines, so you use EC2s. Instead of network card physically present, we give you ENI, Elastic Network Interfaces. Instead of a network switch being given to you directly, we provide you network connectivity through subnet, so you can logically create create isolation through subnet. And instead of router, we call it routing tables. And firewall solution, we provide through security group and network ACL. And internet router, you can compare it through IGW. So if you relate it, there is not very different components we are using. The way we implemented could be really different. So that's what we have seen here. And obviously a unique component exists. We put all these things together into a box, and that box is what we call a VPC. So that is how networking in AWS actually works. So keep that in mind, that cloud is not very different from what you were doing. Only thing is we have virtualized it a lot and we have automated a lot, so you don't see the nitty-gritty details behind the scenes. So that is the first analogy I want to talk about. Another was about CIDR ranges. So we have subnet mask, right? Think of subnet mask as your hotel room numbering. Let's say I have a hotel which has 5 stories, and on that 5 stories there are 5 rooms, or let's say 15 rooms on every floor, per floor. Now if I have to number these rooms, what I would start with, like if this room number is 868, probably that means that this room is on 8th floor and this is the room number 68 here. But this 3-digit format may not work for a hotel which has 10 floors or which has 100 rooms. So what I have to do now, I have to come up with a bigger number in which I would keep 2-digit for my floor numbers, and then I would be keeping the remaining 3 digits for my room number here. Similarly, when you are creating a network address, you could say I need more floors or I need more rooms, and then you can adjust your subnet mask to /24 or /16 or /17, whatever number comes to your mind. So basically what you are doing, you are increasing bits here or increasing bits here, and that gives you more room to keep your network ready or keep your applications IP available. So that's what I prefer to explain as a CIDR mechanism for you. What else? Some more analogies. Obviously I don't have time. I consider a route table as your Google map. Let's say physically you have a place to go. Let's say you want to go to airport. Obviously you don't remember the path. So what you would do in that case, you would put the destination into your Google map and it will give you the path to go there. Same thing happens with your route tables too. When you do not know where to go, you reach out to route table. Route table tells you, hey, go to this path, go to internet gateway, go to VPN, go to direct connect, and then you reach to your destination. So route tables are basically like a Google map for your application where you get all information there. Now another good use case for visualization of VPC is, this is coming from console. So let me bring that information from console. AWS has recently added a graphical element to VPC where you can visualize all these things. So I am here, I am selecting a VPC in my account, and if you look here, there is a resource map section. This resource map would give you a visual cue of where your subnets are, who is connected to whom, what route tables are used. So if you see this, I have a VPC. In that I have 4 subnet. First subnet is public A, another is private A, then public A, public B, private B. They are into different region, and by clicking them I can see that which specific route table is being utilized and which specific gateway is being connected. Or if I want to see who can access internet, so I can clearly see public A and B can access it, but my other subnet cannot access internet directly. They have to go through net gateway. So this resource map is a good visualization of your environment of VPC. So please check resource map within your VPC. Now another analogy I have is for security group and network ACL. Think, let's say you are living into a closed compound, and in that compound you have these dotted line, which is the boundary of the compound, that is your VPC. Within that there are multiple buildings, these are your subnet, and within those buildings there are apartment. These apartments are your EC2 machine, and the door governing that apartment is your security group. It is protecting that specific apartment, that specific EC2. And if a building is having multiple rooms in that, maybe you have a security guard who ensure that whole building is protected. That is your network ACL you can think of. So network ACL is protecting your whole subnet, as you could see here, whereas security groups are protecting only your EC2 instances or specific instances within that. You could have utilized that. So that's how differentiation can be. Whole building versus individual houses, that's the security group and network ACL is. Another analogy I have is for VPC peering. If you travel with your kids and you want to stay in a hotel, you may ask them that if you have a connected room. So connected room ensure that we can directly access. So you can stay into one room with your partner, and the next room you can keep your kids, and then you can open the door. But this door can only be opened if both sides agree. It cannot be opened from one side. Same thing in VPC peering. When you want to peer, you have to initiate a request, and another one VPC has to accept the request. Then only the peering connection happen. Now, because of that, you don't have to go out from your room and then enter into another room. Internally, you have created channel to connect to these. So that's what VPC peering is, where you are creating connected rooms and going through that. Last analogy, and I'll then give it to Prasad, is about site to site VPN versus direct connect. If you are taking a commercial flight to go from point A to point B, you are using the public network which is available, public flights which are available. You are sharing your flight with others also. That is a commercial flight you are taking. Only the limitation is you would be limited by the time they take it. You will be limited by other passengers. That's what commercial flight is. Same thing is VPN. You are not using a dedicated flight. You are riding on existing public internet, and that's why it is a site to site VPN. Whereas when I am having a private jet is my direct connect. It only serves my purpose. I am only traveling in that. Nobody else is allowed. I could decide how much speed I want to go to. I could decide which destination I want to go to. So that's what could be my private jet example you could have utilized for. So there are more analogies, but obviously there is a time constraint. I will send you some additional links, and you can check previous BESA sessions also, where we explain these concepts in easy to follow session, easy to follow analogies. And if you have any feedback, any suggestions, let us know, and we would be happy to add those components into these sessions. All right, and hopefully everyone is having a better picture and understanding. And now let me stop screen sharing from me, and I would add Prasad to stage. Let's go ahead and see these things. Hey Prasad,
Hello,
do you have any
everyone.
screen to share?
Yes, I do have screen to share. I'll share it in a moment. I'll anyway share it. I'll present it in a moment. Hold on. So we were thinking about because BESA has always been a combination of both technical skills and behavioral skills. Like a solutions architect does mean that uh, as important as your technical skills are, equally important are your soft skills. And because of the time constraint, we are not able to cover this time. But we are actually covering the behavioral skills in the role plays. And that's what I wanted to highlight in this session, taking specific examples about how in the role plays every week that you're seeing between like Nicole, Sharik, Ashish, Parna, Richard, that they have been doing, how they have been actually like showcasing their behavioral skills while they are having those customer conversations. And that's what we do on a daily basis when we have conversations with customers. And why I want to highlight is that now when you will look into those videos, I'm sure you must have noticed, but in case if you have missed, you'll be able to identify, okay, this is the kind of behaviors that you should be showcasing when you are having those conversations. Or as solutions architect, these are kind of skills that you need to develop. Communication skills is very important. And communication skill does not mean fluency in English. That's one part to it. And there are a lot of people who are not non-native speakers, which is completely fine. Communication skills means that you are able to understand what the customer is trying to tell you, and you are able to explain them what you want to explain. There is no, miscommunication in that. And we'll look into that in a bit more. And I need to be conscious of the time also. I know I'm going at the tail end of 15 minutes. Should be enough. Okay, let's. The first thing is, one of the superpower of us as solutions architect is that we can take any complex topic and explain them to, I would not say layman people, but to different stakeholders depending upon what level of technical knowledge they have. So the first thing that you need to be good at as a solution architect is understand your audience. And we do a lot of things for that. First of all, we can ask some icebreaker questions to understand what their technical level is, or simple introductions while introducing. When you are listening to them, you will be able to understand whether your stakeholders are technical teams or your business leaders or C-level executives. And you need to tailor your message accordingly. Irrespective, you have to explain things in plain language, provide analogies and examples. We emphasize this on a lot, and Ashish, as you have seen, is a master of this. Uh, and it's really important so that they can understand, because when you explain it through an analogy or a story, it sticks in your mind. You remember the whole conversation, not just the technical aspect of it. And leverage the visual aids, another very important tool to ensure that you are leaving a lasting impact. And I'll give an example of how this has been used. So if you remember in the first session, week 1, when Nicole and Sharik were talking about cloud, just simple plain, what is cloud, right? And why cloud computing. They did not talk about this. They talked about it in the cloud in the later sections, but they started with an example. And Nicole did a fab job in explaining, or providing an analogy about the farm, restaurant, and supermarket, and how that relates to the cloud computing, so that any person would be able to understand it. So people who have been very new to cloud, even they would be able to make that relatable connection and understand how things work behind the scenes. And then she did go into a bit more deep to talk about each of the aspects of the advantages that you will be getting, explaining with the examples. Why I put the screenshots here? Because there are timestamps here that you can see. And if you want to go back and to make the relationship to understand how solutions architects do, explain it to customers. Now, talking about uh, to different stakeholders, right? Now, one of the superpower is that we as solutions architects should be able to talk at 10,000 foot level to the business leaders, C-level executives, and even at a very deep dive technical level. So when we talk about at the high level, 10,000 foot level, we should be able to understand what their business goals are, what their requirements are, what their constraints are from a strategic perspective, and that really helps so that you can accordingly respond based on what the requirements are. And you will be able to use, like, simple non-technical language uh, if you understand what they actually want to achieve. uh, Gregor Hope talks, I'm not sure if you have heard of Gregor Hope. We'll put the link. He has written multiple books. Like, one of the recent book he has written is on platform strategy. Before that, he has written a book on cloud strategy, and he always takes examples of cars to explain things. All right. And that's kind of the way he's able to explain it to non-technical people also, because a lot of C-level executives, believe it or not, they would fancy cars. They would be having, like, cars, they understand the engines and stuff. So he uses that to explain how you can build platforms on top of it. So think about any specific analogy that you would be familiar with and you think the audience would be familiar with, and build on top of that. Focus on why and what of the solution when you talk about when you talk to the business stakeholders, rather than like how you're going to do it, because that's when you start zooming to technical levels. And it's always important also to think about what's the meeting. If it is the first meeting, you will not start zooming to technical details, even if you have technical stakeholders, unless they have very specific ask, like what today Parna and Nicole were doing was probably a third meeting or a fourth meeting discussion. When you have zoom, you have understood the entire problem statement and you're talking about the solutions, looking into the architecture and stuff. Yes, from technical teams perspective, you would be understanding what SMEs are there. Even in technical, there will be different kinds of SMEs. There will be networking SMEs, there will be security SMEs. There's no point in talking about network details to a security SME and vice versa. There is, depending upon how much the overlap is, but you need to understand in your room which SMEs are sitting and accordingly tailor your message. And then you can go into the architecture, design patterns, so on and so forth. And now this is where the third point: use accurate technical terminology. Now it is important that you leave all the analogies aside and you start using the industry standard best practices, in terms of terminologies, because now you are talking to deep technical people who are implementing the solutions or who have been implementing solutions for long. So they would be able to understand your language, your technical language, and it's better to ensure that you're talking about the same thing, so using the industry terminology. And obviously there will be a lot of back and forth or questions that will be coming. So you need to be prepared as a solutions architect to dive into that granular level to explain them the problems, the challenges, and any trade-offs. And why I'm talking about that is, in the first session, again, if we talk about, then Shari started explaining about compute on AWS. Now here, after giving all the analogies and bringing them onto a similar page at what a cloud is, then they started talking about the instances, container serverless, and hinted that if you want to dive deep more, here is the EDA. We can talk about it more. He did not talk about it in detail because it's still the first meeting, but hinted that this is what we'll dive deep if needed. And then he did talk about each of the different compute type: instance, container serverless. Talked about each of the instances, not going into the architecture diagram, but a bit more into how you can leverage these, like on-demand instances, savings plans, how it's going to help you in your business. So you can see that how from let's say a 10,000 feet level, they started coming into 8,000 feet level, but still remaining at a high level so that they are still speaking to the business stakeholders. But the second, uh, I would say, important aspect of solutions architect is understand the problem accurately. Because if you don't understand the problem, your solution might not be fitting uh, the actual issue that is there at hand for the customer. It's very important to reiterate to ensure everyone is on the same page. And for that, active listening. And one of the superpower that I call for solutions architect is that we listen more than we speak. In most scenarios, especially when you have had those multiple conversations with multiple customers, you have experience and you have seen different kinds of scenarios before. When you walk into the room, within first 10 minutes you'll be able to understand what the potential solution would be. But we are not going to tell that, okay, hold on, this is the solution that you should be implementing. We are going to understand their entire problem. We're going to listen more and more, because every customer is unique, every customer problem is unique. Though there might be some generic solutions, but try and understand what their exact issue is or problem is, or what pain point they are trying to fix. So actively listen to understand their requirements, ask clarifying questions. This is very important, and you must have seen this in the conversations, multiple conversations that they have been having in the role plays, that we keep asking questions to understand uh, what we are trying to achieve. And yeah, seek additional context or background information. Reiterating the problem is very important so that everyone is on the same page, and this ensures that if there is any misunderstanding in your understanding of the whole situation or the solution that you're going to propose, stakeholders will be able to point it out. So in case if there are any gaps, you this is your chance to fill all the gaps. And once you have this full information, then you can start brainstorming about the solution. And when we talk about solution, we also always never talk about one solution. We talk about options and trade-offs. If you remember, it depends. So we solutions architect, we do not give an exact answer, because generally the answer depends on the situation. And that's what we try and clarify here by having those conversations with the customers. Now, a good example here is when Nicole and Richard were talking about IAM, more specifically about the principle of least privilege. Richard said to Nicole that we have a way how we manage the accesses on prem. How is it going to work on the cloud? And Nicole explained about the principle of least privilege, but also explained upon why principle of least privilege is important. And that's what is needed. We need to explain why before we explain a terminology, or we tell a terminology, we explain what is the reasoning behind it, what's the thought process behind it. And then she went on to explain about the long-term credentials and why it is not the good thing, and how you should be managing your users, how you can start managing 1,000 users, you will not be able to. So that's where the group and the roles comes into picture. So she did it in a very logical manner, and it's a good thing for you to have a uh, look to just the behavior. See, technically it's all accurate, and there are 10 ways to explain a technical thing, but the way it makes sense to everyone in the room, that's what is more important, and that's what we as solutions architect are actually trying to do in every conversation. Effective whiteboarding skills, another very important thing. And now in the virtual world, we do this virtual whiteboarding, but when we have a chance, we try and have the physical in-person whiteboarding. And it's really important. uh, Whiteboarding is not only used for architectures, it's also used to capture the problem statements, next steps, and everything. But yeah, mostly it is used to explain technical concepts in a simpler manner through the architectures, right? So for example, if you see this particular where Richard was trying to explain, nice diagrams, neatly cleaned, with different colors, and anyone who would be following would be able to understand. So it's very important that the tool does not matter. As you can see, it's just the paint that is being used. You don't need to have fancy toolkits to do effective whiteboarding. It's about how you visually represent it. And obviously, at some point, when you are in the flow, it will ultimately become like this, which would not make sense to the people who are looking at it. But anyone who had been following it would be able to understand the whole flow, right? So in effective whiteboarding, start with a base, build up gradually, and then show it in a way that they are able to explain it end to end. Anyone who is knowledgeable will be able to understand what's happening here, but anyone who is new, if you present them this, they might not be able to understand, which is okay, because they'll have to start from the very beginning and see how it has got built up over the time. Now, the next thing that I would like to talk about is taking a step back and look at the basics. When someone asks you a question, right, as solutions architects, we get asked a lot of questions on a day-to-day basis. When you get asked a question, always take a step back and look at the basics or the big picture. I generally say the big picture is always the basic, right? So you can use it interchangeably. You can either call it talk about the basics or talk about the big picture. It's the perspective that you would look into. For example, when Richard and Sharik in week 3 were talking about storage, and Richard, simple question Richard was, I have these different kinds of storages on prem. How is it going to translate when we move to cloud? And Sharik, instead of explaining, starting to say that we have S3 and we have EFS and so on and so forth, he said that, like, let's take a step back and let's look into all the different kinds of storages that are there. Then we look into the storage types, explain the features of each of it, so that we ensure that we are all on the same page. And then started diving deep into, okay, now we have EBS and we have SSD drives and HDD drives. And then Sharik also asked question to Richard, that which of them are you using in on-prem currently? having to coming to this level and then asking that follow-up question would mean that Richard now understands that, okay, why Amazon EBS is being used for which scenario and with SSD or HHD, because now he'll be able to relate completely about their on-prem knowledge versus what is at offer on the cloud. Cool. How are we doing on the time? Oh no. Okay, I'll have to fasten a bit. Explain the full spectrum and options available. So this is again not to confuse customer, but we have to uh, uh, explain them end to end. I'll skip few things just to give. I had an example here, but I'll skip that and I'll talk about the example about in the week 4. Parna question was, uh, we are moving to cloud, we are using managed services. How does the monitoring work? Ashish, instead of telling that monitoring is going to be working like this, he talked about what do you mean by monitoring. Monitoring is important, but it can be performance monitoring, it can be utilization monitoring, it can be health monitoring, it can be security monitoring. And the customer is like, oh man, I did not even think about all of that. Then you need to think about the business metrics, the systems metric, put all the options on the table, and then start demystifying it and talking about which services can help you with what. Then that also helps the customers to understand that what they actually want to monitor, right? Monitoring is one thing, but what specific aspects you want to monitor. And that's what Ashish tried and explained that with this whole thing. Again, not to confuse the customer with all the options and different things that we have, but to ensure that they understand what they want to do. Finally, time management. That's what, as you see, we all are failing at, and Ashish needs to come on almost every session on the screen to like do the time check. We when we go into a meeting, we always have these checkpoints at every time to ensure that we are in control of the uh, whole session, and we always have a fallback that we will have a follow-up meeting or something like that. But yeah, but this is something that we almost everyone as solutions architects, we struggle because there are so many things to uncover and so many things to explain. With that, that's pretty much that I have. Ashish, you can take it over. I know I'm probably a minute over.
That's completely fine. But yeah, that was an interesting discussion. Time management is obviously facade that we all have to work. The
Yeah.
challenge is like we have so much information and we want to relay as much as we can. But in customer conversation, less is more. So initially start with less and then keep on adding. If the question comes, you are not there to show your knowledge. You are there in a customer conversation to help them solve the problem. So do not show them that, hey, I know all these things, I know these specific things or technologies. Yeah, I got a new title now, Scarecrow. Yeah, I love that. Yeah, but be aware about time management. It's important because you may still have time, but a customer may have another important meeting to attend to. So please make sure you try to finish it. And if you can't, say that I'll follow up. I will set up next meeting. I will send you some more detail, and I will send you these information, and we can have another time again. And you are not just saying for sake of saying. You obviously have to follow up. That is another important aspect of being an SA, that you may have to follow up with customer to understand what they have understood from the meeting and any additional pointers you could provide to them. So thank you so much for that, Prasad. All right, and keep your feedback coming, everyone, and hopefully that would help us in getting the best out of it. Thanks, Prasad. And I'll talk a little bit on the giveaway side. So as you know that we every week giving away a book which is Cloud Career Journeys, and we are giving 10 sandboxes from from WizLab. So thanks for that. So we are also giving 50% discount on ebook, and if you're getting started, you could check Starter Kit where there is a lot of information available, and we are selecting people based on their active engagement. Now, active engagement could be resharing these posts, talking about your learning, putting it into a blog post, maybe putting some insightful information on LinkedIn or social media. And people who are watching afterward, it could be asking intriguing question on YouTube comments or sharing this video in your network. So even if you are watching it late, that doesn't mean you cannot be part of it. Just make sure that you tag us so we know that you are making some shout out for BESA program and the learning you have. Your learning are important. Even if you do not talk about BESA, that is still fine. But whatever you have learned, if you are sharing, it is also helping you to build your network. And I want to explain who are the winners for the last week. So all these people are winners. We haven't still sent information to all of you, but probably in a day or two you would be able to get it. If you are into this list and if you have not contacted us, please send us email addresses so that we can facilitate your access. So Lakshmi, congrats on winning the book, and all other congrats on winning the 3-month lab access. Now
Yeah,
that's
in the
all
next session,
I had.
probably,
Go ahead,
Ashish,
sir.
what we can do is we can show how to use the WizLabs, because we have got a couple of queries, right, about
Agree.
3 months access, that how the sandbox can be utilized. So next session, we'll probably take 5-10 minutes to explain that.
Yeah, we should be doing it because yeah, a lot of people are interested to know that how this sandbox work, what can I do, and there are questions that how I can practice. So we will talk about that. So thanks everyone. I'll add again everyone on the stage: Sharik, Nicole, and Perna. Kapil dropped off probably, but yeah, thanks everyone for supporting us, and keep your questions coming. We would answer as much as we can. And Sharik, you had answered so many questions. I don't know how you type so fast. And obviously, Parna and Nicole, you were really great in
Just
showcasing
want
it.
to
And
add
Prasad,
one
you
thing.
did like a great job. We had this idea of having this behavioral track just before start of the session, and within the session Prasad created that timestamp and slide, so kudos to that. And we would keep up coming with more innovative ideas to help you understand. So give us feedback, anything we can do differently to make your learning better, we would be happy to do it. Have a good week everyone, and we would be seeing you again next week. Thank you so much.